For the final, I choose option 1 that replicate the TensorFlow project. I take this one, the image classification for cats and dogs. This is my notebook. So after importing the libraries, the first step is load the data. To import the package from the URL and use the carrots get file method to extract the package. And it's the directory. I check the path that's on my computer. It's data sets and this folder, cats and dogs filter, and then the train. It has train folder and the validation folder, and each folder has a cats folder that contains 1,000 images, and the dogs folder has 1,000 images also. And I calculate the total. The total training image is 2,000, and total validation images are 1,000. So the next step is data preparation. I choose the batch size as 200 images, and epoch for 10, and the height and the width for 150. Here, use the image data generator to rescale. Because the neural networks prefer smaller data as input value. Basically, it's between 0 to 1. And then load data from the disk. Use this method, flow from directory. So here, batch size is batch size. Directory is from my train directory. I closed my folder. And the shuffle is true. And the size resized to 150 to 150, multiple 50. Mode is binary. I think because it's just cats and dogs. Then it's load the validation images. So here from the validation directory. So next step is visualize the training images. For the next method that download like the one batch like 32 images. Here's a name it as sample training images, and I also let the labels. I check the images. It's just the matrix. I don't know. It's 4D. 1, 2, 3, 4. And for the labels, because it's just cats and dogs, so it's only 0 and 1. And I found it's a float. It has a point here. Oh yeah, flow 32 data type. And then for the first 5 images. So because I want to show the labels, so I modify a little bit for the TensorFlow tutorial. Yeah, they didn't show the labels, so I modify a little bit here so that I can see cat. Basically, it's cat is 0 and dog is 1. So correct, they are correct. And then we continue to create a model. So we will use the convolution neural network. It's basically, let me see. We can simply say that this is the input layer, and this layer is the output layer, and here is the hidden layer. We can see these hidden layers are the convolution layers. And for the input layers, like the images, we just make the ND arrays to 1D. I can't explain it. Here it's input layer and convolution layers. Convolution layers. And then it's dense layers. And for the output. And it's the filter. So it's like the window size. So here the field size is 3 by 3, and the window size is also 3 by 3, and you will get the weight, the total weight, like this function. You get a total weight here on the destination layer, so you get. So here we use the model sequential. It's the I can see it's the input layer, and then the first layer, the first convolution layer. It's 16 filters, and the window size is 3 by 3 actually, 3 by 3. Here the padding same. I check the meaning. Same means that half padding make the size of outputs be the same with that of outputs when strides equal to 1. I'm not very clear about this. Just have a little bit of concept. And the input shape is 150, and the 3, I think it's the color, that RGB. And next layer for the max pooling. And again, one more layer, one more layer, one more layer. Also, how many? 1, 2, 3, 4, 5, 6. Here we have 6 layers. And then flatten to list for 1D and the dense layers. And the last layer is the output layer, because we just want to know it's a cat or it's a dog. So the output is just 1. And then compile the model. Okay. Compile the model. Here we can see here, this is the 16 filter. And the 32, 6, 3, 4. That's our model. And then we train the model. Here we use the feed generator method to train the image data generator class. We have step, we have epoch, and we also put the validation data. Now we see this is the train, the accuracy of the train data and the accuracy of the validation. At the 10th epoch, we can see the accuracy of the train data is about 81, and the validation is only about 71. Let's do the visualization. Here, make the here it draw the two the two figure, one for the accuracy, one for the loss. So it used the subplot to draw the two figures together. So one row, 2 columns, one row, 2 columns, and the first one is for the accuracy. So for the accuracy, and the second one for the loss. And for the from the figure, we can see the training accuracy is higher than the validation accuracy. It's a lot higher. So there's a problem of overfitting. Then we need to transform our augmentation, our data. The TensorFlow introduces 3 augmentation. The first one is for the horizontal flip. They use the image data generator. So just stay the horizontal flip true. Just flip horizontally, flip the image a little bit, like the cat here. A little bit for this cat. And then a second The second way is randomly rotate the image. So we can see it's obviously that rotate what degree? 42, I remember. Yeah, 45. Sorry, 45 degrees rotation. And the third way is zoom. Zoom 50%. So let's see one example. Zoom bigger, smaller. Now we put the three methods together. Here, rescale, rotation, and resize, and horizontal flip, and the zoom. Now we load our data from disk, from the train directory. We can see it's 2,000 images. And then take one example, what it looks. Yes, rotation, zoom, I think zoom. Anyway, they put the three features together. So now we create a validation generator. Again, rescale and batch size, and load the validation image. And we also need to drop out. Drop out means like if the dropout value is like 0.1, that means dropping out 10% of the output units for. So now we are gonna create a new model. For the tutorial, the first layer they choose 16 field, and then drop out 0.2, and then 32 field, and then 64, and then drop out, and then dance to 512. I change a little bit here. On my model, the first convolution layer, I use 32 filters, and then max pooling to 2, it's okay, and the drop out to 0.25, and then increase the filters to 64, and drop out the same, and then increase to 128 filters, and max sales keep the same, and drop out again 0.25, and then flatten the layer, and dance to 128 filters, and then I only need one output. Here we all use the activation of ReLU. For the ReLU, is that correct? ReLU. It's just for slide window. The window size 3 by 3, and the field I can see they just put the total weights here. Then filters, the 3x3 filters. This one -1. This means black, and 1 means white, and 0 is gray. So 3 colors. Activation. Now I want to see here activation. It's like the value on the point. It's between 1 and 2 that assigned to the so again compile the model. We also we here because we only have cats and dogs, so we can use the binary cross tropy. And then again, this is the summary. And then train the new model. Again, use the generator. Here is the train result. It's much lower than previous one. Then we do the visualization, and again the same way. The first one for the accuracy and second one for the loss. Here the validation accuracy is higher, a little bit higher. It's actually the validation accuracy and the training accuracy are very close. They're almost the same. So that means it's reduced overfitting. I tried many methods. I tried many different models, but I found the results are similar. They are after also what's that transformation augmentation and the dropout. The score almost the same, around 50 to 60 points. So that's it.